So for the last lab for test one, covers the test one material, we're going to be looking at graphs of functions. So what this lab talks about first in the instruction sheet is how to actually plot points on a graph. Everybody should know how to plot points on a graph. This is all review, just with some of the terms, the quadrants, but you can see here, if you have a point 2 comma 3, you should know how to actually plot that point and where it lives. So the first page is a review. Second page again is another review. If you want to sketch the graph of this, and that is a function, it can be written with f of x. And you're going to go on to see that you can either write functions with f of x or with the letter y. They mean the same thing. If you were going to sketch this, then you can calculate some points. You are free to choose x, so that's the independent variable. Once you have made your choice for x, though, y is predetermined. You don't get to choose what y is willy-nilly. So if x is equal to 1, then you figure out what y is by plugging 1 into this equation, and you get -6, and this gives you a point on the graph, 1 comma -6, and then you can plot that. So 1 comma -6 is right here, and with all of these other points, you're free to choose x, but then you have a y that is determined, dependent on your choice for x, and you get all these points. And you can see here in the picture they've been plotted, and then it should have a shape that you should be able to draw a raw sketch of. That's what we did back in the day. Now, how can you tell if you're given a graph that you actually have a function? And this is called the vertical line test. So to tell whether or not a graph is a function, the vertical line test is, so suppose you have these drawings in blue. How can you tell whether or not they're a function? If any vertical line intersects your drawing more than once, you do not have a function. So let's come over here, and I'll draw a couple of these. Okay, and I'll draw them in blue. And then what if I suppose I just have something like this? And I might draw one more in here. Okay, so let's see if we can decide which of these are the graphs of functions. I'm going to apply the vertical line test. So here's a vertical line, and it only hits it once, once, once. So this arrow means it keeps going like that forever. So the vertical line hits it once because that point is contained. Not at all. Not at all, because it's obvious that this point is hollowed out and not contained. Once, and that arrow means that the graph's going to go on like that forever. This passes the vertical line test. Any vertical line that you can draw only hits it at most once. This is the graph of a function. Now, if I come to this other picture, that vertical line only intersects the graph once, but here it intersects the graph more than once. This is not a function. So all it has to do is to break the rule once, which it has here. This line intersects it more than once. It's not a function. This is a function. Any vertical line I draw only hits it at most once. So this is a function. And this only hits it once, but what happens here? Infinitely many points. So between this part of the graph and that part of the graph, you've got infinitely many points here on this blue line segment. So this is not a function. So if we go back to here, it should be obvious this picture is not a function, does not pass the vertical line test. This one does. Now, we've had domain and range in the last lab. How do you find the domain and range if you have the graph of a function? Well, the domain is found by using the x-axis to measure how wide the graph is from left to right. You give your answer in interval form. And then the range is found by using the y-axis to measure how tall the graph is from bottom to top and leave out any gaps. Again, you give your answer in interval form. So let's actually do that with this one here. I'm going to copy it and we'll go over to this blank. Okay. All right. So let's get the domain. Let's do the domain first. The domain, you use the x-axis to measure how wide, starting from left to right. So this is the leftmost point on the graph. Oh, first of all, this is a function. Sorry, it passes the vertical line test. Doesn't touch it at all. Touches it once. Not at all, not at all, not at all, not at all. So it will never intersect it more than once. So it is a function. Now what about the domain? Use the x-axis to measure how wide from left to right. So I'm starting here. This is the leftmost point. It's filled in. So I'm going to draw on the x-axis where we start. And then moving left to right. If I look down, if I look up, there's always a point. There's no gap. And I keep going, and we have our rightmost point coming up. This is not included, so I'm leaving it out. Now, this red piece that I've drawn is the domain. I need to tell what that is in interval form. And from the grid marks here, I've got -1, -2, -3. And from the grid marks here, 1, 2, 3, 4, 5. So this red section from left to right starts at and includes -3. And then there's no gap in the graph, and we end at 5, but it's not included. And so the symbols with the square bracket and the parenthesis are very important. And if we go back to that, you can see here I've done that on the lab instructions, and it shows what the domain is. Okay, now how do we get range? With the range, you use the y-axis to measure from bottom to top. So I'm going to use the y-axis. Now I look for the bottommost point, and that's going to be here. It's not included, so I'm going to start with that. Now, as I'm looking from left to right, if I see at least one point, there's no gap. So looking to the left, I've got lots of points, lots of points. And then I get up to here, and all of these points are tied for the highest point. And so we have inclusion there. And what I've drawn in green is the range. Now you have to read it from bottom to top, and you have to give it an interval form. So with these grid marks, -1, -2, -3, up to +1 is where that is. And so the range from bottom to top, I start at but do not include -3. Then move up to and end at +1, and 1 is included. So again, we can go back to here, and this shows how we got the range. Okay, so let's do another example. Let's find the domain and range of this one. Come here and get rid of that. All right, so it is a function. I hope we can see that this passes the vertical line test. Not at all. Not at all. There's no point there. Once, 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 once. Not at all. Not at all. I mean, these are supposed to be vertical lines. Once, 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 and it's going to keep going like that forever. So it does pass the vertical line test. So what is the domain going to be? Use the x-axis to measure how wide. So going from leftmost point on the graph, I'm going to start here, but I am not going to include it. And then when I look up, I always see a point. So we don't have any gaps. It's filled in. And then here this ends, and I'm going to fill in that. Then I have a gap. So I'm going to leave this bit out, because if I look up or down, there are no points. I'm going to pick it up again when I get to here. So that's going to be filled in. And then if I look down, I can see points. And this arrow indicates that this is just going to keep going like that forever. That's what that arrow indicates. And so I'm going to have this rightmost part is going to keep going forever if I'm measuring how wide it is using the x-axis. Now what I've drawn there in red is the domain, and I just have to read it off from left to right in interval form. So -1, -2, -3, -4. Then this is +1 at this gap. So reading the domain off, the red part, from left to right, I'm starting at, I do not include -4. I go up all the way to -1 and include that. Then there is a gap. I pick it up again at 1. 1 is included. And then it goes on forever with no gaps. That is the domain for this example 3. So let's check it. All right, so you can see what was drawn there in red. And so we put the two parts together, and we have our domain. Now let's look at range. If you're going to look at range, use the y-axis to measure how tall from bottom to top. We have to be really careful, something I want to point out. So you look for the lowest point. That is the lowest point on the graph, and it corresponds to here on the y-axis. Now if you look left or right, there's no gap. You always have that filled in. Now be very careful. Do not stop it here and then say, oh, I have a gap. You do not. Why? Because this arrow here means that this blue part, that the actual graph goes on forever. So if I'm looking to the left or right, there's always going to be a point. And notice that if you hadn't extended it like it should, you might make the mistake and get up here and say, oh, it ends there. It does not end there, because you have this portion. Oops, that should be blue. You have this part of the graph that goes on forever. And so when I'm doing the range for this one, if you look left or right and can see at least one point, there's no gap. If I look left here, there's no point. But if I look to the right, there actually is out there somewhere. And if I keep looking right forever, it's going to go up. So that is what the range is going to look like. And if I fill in, now you do it from bottom to top, so that's -1, and this is -2. So the range from bottom to top is going to start at and include -2, but then it won't have an upper limit. So again, let's check this with the, okay, so that's what we drew here. And now let's go on to example 4. So we can say goodbye to that one. This is a function. Again, it passes the vertical line test. So here's a vertical line, doesn't hit it at all, 0 times 0. This does not intersect the graph because that is hollowed out. Once, none, none, once, and none. So it will only, any vertical line will only intersect it at most once. It is a function. So now what about domain? Use the x-axis to measure how wide from left to right. So I'm going to include that. And then it's unbroken. And then here that is not included. Then there's a gap, and we pick it up again here. Okay, and so now I just need to, if that's -5, this here is -6. If that's 1, then this is 2, and that's 3, and then 4 and 5. Okay, so now I can write the domain from left to right. I'm going to start at and include -6. And it's unbroken until I get to 2. 2 is not included. Then we have a gap. And then I have a second section that starts at and includes 3. And then ends at 5, but 5 is not included. So that's my domain. And let's check it. Okay, so there's our domain and drawn in red. And now let's do the range in green. We want to measure the y-axis, use the y-axis to measure from bottom to top. So here's the lowest point. That's where I'm going to start. And moving up, if I look left or right, I can see points. So there's no gap. When I get here, if I look right, there's not a point. But if I look left, there is a point. There's no gap. And so I'm going to keep on until I get to here, and that point is included. Then if I look left or right, nothing until I get to here. If I look to the right, I can see at least one point. So I just have that singleton there. And then when I get past it, I look left to right, I can't see anything. So what I have in green is my range. From bottom to top, down here is -10 at the bottommost, and it's included. And we're solid up until we get here, which is at -1, and that's included. Then we have a gap, and then we have a singleton, just this point, and that's at 1. So you can put it in curly brackets, or you could put it in square brackets. You cannot put it in parentheses because that wouldn't be correct, because parentheses means it's not contained. WebWorks seems to want that notation. All right, so let's try again. Let's look back at the sign, and that's what we have there. Okay. Now, how do you evaluate a function if you have it presented as a graph? Okay, so I'm going to take this example 5. Okay, and come back here. And I might want to make this a little bit bigger. So, first of all, what we have here is a function, the graph of a function, because we can see that it passes the vertical line test. 0, cuts it once, cuts it once, 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 once. Here it does not cut it at all. Not at all. Once, 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 once. Now what happens here? It does not cut it there because that point is left out. It does go through there. So it only intersects the graph once. So that's okay. And none at all. So this is definitely the graph of a function. What is the domain and range? Well, we can see domain. I'm going to start here and then come here. And so that ends at 1. And then I pick it up again at 2, but it's not included. Now we want to be really careful here. It's true that that's not contained, but I have a point here. So I do get it filled in the end. So my domain is going to be, reading this from left to right, -9 to 1. 1 is not included. Then there's a gap. I pick it up again at 2. And then I continue until we get to 7, and 7 is included. Okay. So let's check that. Yeah, it's wrong to write it like this because you don't have 2 gaps in it. Okay, so the domain that you want to write is how I have written it. Okay, so, and what is the range? Well, you use the y-axis to measure how tall from bottom to top. That is my lowest point, and it's contained. And then as I'm going up, if I look left or right, I can see points. All right, when I get here, if I go to the right, I can't see a point, but I can see more than one point to the left. Left or right, I can always see points. When I get here, I might not be able to see a point there, but there's one there. There's more than one there, so no gap. And then finally, my highest point is there. So I don't have any gaps at all from bottom to top. And bottom to top, I went from -3 up to 7. So the range is going to be from -3 to 7 inclusive. And let's check that. -3 to 7 inclusive. Okay. And again, don't try and make sections of it because there are no gaps. There are no gaps. It's wrong to write that. Okay. All right, now let's go back to the next part of the question. let's see if we can find these. So what is f evaluated at, let's look at this one. What is f evaluated at -9? So how do you do this? Okay, so this is a function, and we're going to call it f. So what a function does is, if you have a point on the graph of f, then what f does is it maps the x-coordinate into the y-coordinate. And so f evaluated at the x-coordinate is equal to the y-coordinate. So that's kind of a shorthand, but f evaluated at an x-coordinate is equal to a y-coordinate. So the important thing is that x comma y is a point on the graph. So if we want to find f evaluated at -9, you need to find a point on the graph whose x-coordinate is -9. So here's -9, and this point here has x-coordinate -9, and its y-coordinate is 4. So what does f do? It maps the x-coordinate into the y-coordinate. So f evaluated at the x-coordinate is equal to the y-coordinate. My answer is 4. And it's not the point. The answer is 4. If you write that as the answer, that is wrong. So f evaluated at -9 is equal to 4. All right, let's see if we can do the next one. What's that going to be? Well, this number is the x-coordinate. Remember, f evaluated at the x-coordinate is equal to the y-coordinate. So you want to find a point on the graph of f whose x-coordinate is -8. There it is. What are the coordinates of that point? -8, 6. And what does f do? It maps the x-coordinate into the y-coordinate. So f evaluated at -8 is equal to 6. The answer is 6. All right, and let's go on to the next one. To find f evaluated at 5. You find the point whose x-coordinate is 5. So here's +5. There's the point whose x-coordinate is +5. That point has coordinates 5, 4. And what does the function do? It maps the x-coordinate into the y-coordinate. So f evaluated at 5 is equal to 4, and the answer is 4. Now, what about f evaluated at 2? You find the point whose x-coordinate is 2. Here's 2. I look up, there's nothing. That point is hollowed out, so it's not there. I look down, there's nothing. There is no point with x-coordinate equal to 2. Therefore, f of 2 is undefined. Or you might write D and E for does not exist. Now what about this? F of 7. F evaluated at 7 is equal to what? Find the point whose x-coordinate is 7. If I look up, we don't have a point with x-coordinate equal to 7, but if I look down, I do have a point on the graph. This point has x-coordinate 7 and y-coordinate -2. And F maps the x-coordinate into the y-coordinate. And so the answer to that question is -2. Now for this last part of the question, you're told f of x is equal to 4. If f of x is equal to 4, what is x? Okay, you have not been asked what is f evaluated at 4. That is not the question. And a lot of students will answer that question. That's not the question you've been asked. Now remember, f of x f evaluated at the x-coordinate is equal to the y-coordinate. F of x is equal to y. So this is telling you that the y-coordinate is 4. That's what it's telling you. If f of x is equal to 4, if the y-coordinate is 4, what is the x-coordinate? So you need to find all the points whose y-coordinate is 4. There's one there, there's one there, and there's one there. So there are 3 points with y-coordinate equal to 4. We've got -9, 4. We've got -6, 4. Oh no, we've got 4 points. We've got one there as well. 0, 4. And 5, 4. So this point here is 0, 4. All right, so we have 1, 2, 3, 4 answers to that. X is -9, -6, 0, and 5. So when the y-coordinate is 4, you have 1, 2, 3, 4 points on the graph of f that have a y-coordinate of 4. What are the x-coordinates? And the x-coordinates of these points are -9, -6, 0, and 5. Now let's look at that one. Oops, it's here. Okay, so I've done that. I've marked the points in red. So if f of x equals 4, what is x? It is wrong to say that the answer is 3, because 3 is what you get if you are finding f evaluated at 4. That's not what you've been asked. Okay. So the y-coordinate is equal to 4. F of x is equal to 4 when the x-coordinate is equal to -9, -6, 0, and 5. The x-coordinates of those points. Okay. So finally, if you have something like this, take that back. Okay, let's try it again. All right. You've been told here the point that's on the graph. Because remember, f evaluated at the x-coordinate is equal to the y-coordinate, i.e. f of x equals y. So that's the x-coordinate of your point. on the graph, and that's the y-coordinate. So the point -5, 2 is on the graph. Now similarly, if you're told -5, 2 is on the graph, then that's the same thing as f evaluated at the x-coordinate is equal to the y-coordinate. So they mean the same thing. Okay, so that is everything that you need to know for the Lab 6 and web work. And so I'm going to stop this video.